close your eyes for a moment. Imagine absolute nothingness. No light, no sound, no space, no time. Nothing. Now open them. Because 13.8 billion years ago, everything you've ever known, everything you've ever seen, everything that has ever existed or ever will exist began. The Big Bang was an explosion in space. It was an explosion of space itself, in a fraction of a second so small we can barely comprehend it. A trillionth of a trillionth of a trillionth of a second. The entire observable universe inflated from something smaller than an atom to the size of a grapefruit, and it's been expanding ever since. But here's what should really bend your mind. We can actually see this beginning. When you look up at the night sky, you're not just looking at space. You're looking back in time. Light has a speed limit, 186,000 miles per second. Fast, yes, but the universe is so incomprehensibly vast that light from distant objects takes billions of years to reach us. The light from the most distant galaxies we can observe has been traveling toward us for over 13 billion years. We're literally seeing them as they were when the universe was still in its infancy, just a few 100 million years old. Think about that. You are a time traveler. Every time you gaze at the stars, you're witnessing ancient history. And speaking of history, let's talk about where you came from. Not your parents, not your ancestors, but the very atoms that make up your body. Every single atom of carbon in your body was forged in the heart of a dying star. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of it was created billions of years ago in the nuclear furnace of massive stars. When those stars exhausted their fuel and died in spectacular supernova explosions, they scattered these elements across the cosmos. Eventually, those atoms drifted through space, came together in a cloud of gas and dust, and billions of years later became you. You are, quite literally, made of stardust. We all are. Carl Sagan was right when he said, "The cosmos is within us. We are made of star stuff." But let's zoom out for a moment and talk about scale. Our sun, that brilliant ball of fusion that lights our days, is massive beyond comprehension. You could fit 1.3 million Earths inside it. Think about every mountain, every ocean, every city, every person who has ever lived. All of that times 1.3 million would fit inside our star. It accounts for 99.86% of all the mass in our solar system. Everything else, all 8 planets, their moons, the asteroids, the comets, the dust, makes up just 0.14%. And yet, our sun is actually quite average. It's a medium-sized yellow dwarf star, utterly unremarkable in the cosmic scheme of things. There are stars out there so massive they make our sun look like a grain of sand on a beach. Scuti, one of the largest known stars, has a radius about 1,700 times larger than our sun. If you replaced our sun with Scuti, its surface would extend past the orbit of Jupiter. Saturn would be inside the star. But size isn't everything in the universe. Let's talk about density. Specifically neutron stars. When a massive star dies and collapses, it can form a neutron star, a sphere only about 12 miles across, but with a mass greater than our sun. The matter is so densely packed that a single teaspoon of neutron star material would weigh about 6 billion tons on Earth. That's roughly the weight of 900 Great Pyramids of Giza. In a teaspoon, if you somehow stood on a neutron star, which you couldn't, because you'd be instantly flattened into a layer of atoms 1 atom thick. Gravity would be 2 billion times stronger than on Earth. Time would even pass slower there due to Einstein's theory of relativity. Spend a day on a neutron star, and decades might pass on Earth. Now, let's talk about something even stranger, the space between things. You think of the universe as being full of stuff, stars, planets, galaxies. But the reality is that the universe is mostly nothing, empty space. The distance between objects is so vast it defies human intuition. Our nearest stellar neighbor, Proxima Centauri, is 4.24 light-years away. That means light, traveling at 186,000 miles per second, takes 4.24 years to reach us from that star. In more familiar terms, that's about 25 trillion miles. If you could travel in the fastest spacecraft humanity has ever built, the Parker Solar Probe, which reached speeds of 430,000 miles per hour, it would still take you over 6,700 years to reach Proxima Centauri. And that's the closest star to us. And here's the thing that really puts it all in perspective. All those stars you see at night, all those pinpricks of light scattered across the darkness, you're only seeing stars in our immediate cosmic neighborhood. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. Yet on a clear night, from the darkest location on Earth, the human eye can see only about 5,000 stars. That's 0.0000001% of our galaxy. We are so small. Our entire civilization, every story ever told, every person who has ever lived and died, every empire that has risen and fallen, all of it has happened on a mote of dust, suspended in a sunbeam, drifting through an ocean of space so vast that it makes infinity seem intimate. And we're just getting started. Let's now talk about something truly humbling, the observable universe. When we look out into space with our most powerful telescopes, we can see galaxies stretched across 93 billion light-years of space. That's the observable universe, the sphere of space in which light has had time to reach us since the Big Bang. But here's the unsettling part. That's not the entire universe. That's just the part we can see. The actual universe, it could be infinite, or it could be finite, but so mind-bogglingly large that the observable universe is like a single grain of sand on an endless beach. We simply don't know. We may never know. Think about that for a moment. Everything humanity has ever observed, every galaxy we photographed, every distant quasar and nebula, all of it exists in what might be an infinitesimally small bubble of the true cosmos. Now, let's bring this closer to home, to our own galaxy. The Milky Way is a barred spiral galaxy, a beautiful cosmic pinwheel of stars, gas, and dust. It's about 100,000 light-years across, and we live out in the suburbs, roughly 26,000 light-years from the galactic center. If you could somehow see our galaxy from outside, from a perfect top-down view, you'd see Earth positioned about halfway between the center and the outer edge in a minor spiral arm called the Orion Spur. But here's something that should make you pause. If the Milky Way were the size of the United States, our entire solar system would be about the size of a single blood cell. And Earth would be microscopic, smaller than a speck of dust on that blood cell. That's how small we are, just within our own galaxy. And we're moving right now. As you sit reading this, you're on a planet spinning at about 1,000 miles per hour at the equator. Earth is simultaneously orbiting the sun at 67,000 miles per hour. But it doesn't stop there. Our entire solar system is orbiting the center of the Milky Way at approximately 514,000 miles per hour. And the Milky Way itself is moving through space at about 1.3 million miles per hour, drawn by the gravitational pull of massive galaxy clusters beyond our own. You are hurtling through the cosmos at speeds that would make any science fiction spacecraft jealous. And you don't feel a thing. Speaking of our galaxy, let's talk about what's lurking at its heart. At the center of the Milky Way lies a supermassive black hole called Sagittarius A star. It has a mass roughly 4 million times that of our Sun, compressed into a region smaller than Mercury's orbit. It's so massive that stars near it orbit at speeds of up to 5,000 miles per second, nearly 3% the speed of light. These stars complete an orbit around the black hole in as little as 16 years, even though they're tracing paths larger than our entire solar system. Black holes themselves are among the most extreme objects in the universe. There are regions of space-time where gravity is so strong that nothing, not even light, can escape once it crosses the event horizon, the point of no return. But here's what's truly mind-bending. Inside a black hole, the roles of space and time actually switch. Once you cross the event horizon, moving toward the singularity at the center isn't a matter of choice anymore. It's as inevitable as moving forward in time. You couldn't stop yourself from reaching the center any more than you could stop yourself from reaching next Tuesday. And if you fell into a black hole, something called spaghettification would occur. The difference in gravitational pull between your head and your feet will become so extreme that you'd be stretched like taffy, pulled into a long, thin strand of atoms. It's not a pleasant way to go, but at least it has a fun name. Now let's talk about something equally mysterious but far more abundant: dark matter. Everything we can see, all the stars, galaxies, planets, gas, dust, you, me, makes up only about 5% of the universe. The other 95% is stuff we can't see and don't fully understand. About 27% of the universe is dark matter, an invisible substance that doesn't interact with light but does exert gravitational force. We know it exists because galaxies rotate faster than they should based on visible matter alone. There must be something else holding them together. The remaining 68%? That's dark energy, something even stranger. It's a mysterious force causing the expansion of the universe to accelerate. Every second, the universe grows larger, and it's growing faster now than it was 1 billion years ago. Dark energy is pushing everything apart, overwhelming gravity on cosmic scales. Imagine blowing up a balloon, but instead of your breath slowing down, it somehow accelerates. That's what's happening to our universe. This discovery, that the universe's expansion is accelerating, is relatively recent, confirmed only in 1998. It won the discoverers a Nobel Prize and completely upended our understanding of the cosmos. Before this, most scientists assumed the universe's expansion was slowing down due to gravity. Instead, we found the opposite. It's as if the universe is being pushed apart by some invisible anti-gravity force permeating all of space. And here's a sobering thought about the future. Because of dark energy, galaxies beyond our local group are accelerating away from us. Eventually, in trillions of years, they'll be moving away faster than the speed of light, not through space, but because space itself is expanding between us. When that happens, their light will never reach us again. Future civilizations, if they exist trillions of years from now, will look up at the night sky and see only the handful of galaxies in their local group. The rest of the universe will have disappeared beyond an expanding cosmic horizon. They'll have no evidence that the Big Bang ever happened, no way to know that the universe is larger than what they can see. They'll be cosmically isolated, living in what appears to be an unchanging, eternal cosmos. We are lucky, if you can call it that, to live in an era where we can still see the universe in its full glory, where the evidence of our cosmic origins is still written in the sky. We exist in a brief window of cosmic history, where the universe reveals its secrets to us. Before us, it was too young and chaotic. After us, it will have expanded beyond recognition. The universe is not only vast beyond comprehension, it's also temporary. Everything we see, everything we know, is just a fleeting moment in a story billions of years long. And there's still so much more to discover. Let's talk about time, specifically deep time. The universe is 13.8 billion years old. That number is so large it becomes almost meaningless. So let's put it in perspective. If you compress the entire history of the universe into a single calendar year, with the Big Bang happening at midnight on January 1st, our solar system wouldn't form until September 2nd. The first simple life on Earth wouldn't appear until September 21st. Dinosaurs wouldn't arrive until December 26th, and they'd go extinct on December 30th. all of recorded human history. Every empire, every war, every discovery, every person you've ever heard of would occur in the last 14 seconds before midnight on December 31st. Your entire life will be a fraction of the final second. We are so very, very new to this ancient cosmos. But here's something even more humbling. There are more stars in the universe than grains of sand on all of Earth's beaches. Scientists estimate there are roughly 200 billion trillion stars. That's a 2 followed by 23 zeros. Try to picture every beach you've ever seen, every grain of sand you've ever touched. Now multiply that by every beach on every continent, every shore of every island, every desert with sand-like particles. Even then, there are more stars in the cosmos than all those grains combined. Each one a sun, potentially with its own family of planets, its own story written in light and gravity. And on the topic of planets, we've discovered thousands of exoplanets beyond our solar system, and the numbers keep growing. Based on current estimates, there are at least 100 billion planets in the Milky Way alone. Many of these orbit within their star's habitable zone, where liquid water could exist. When you multiply that across all the galaxies in the observable universe, remember, there are an estimated 2 trillion galaxies. The number of potentially habitable worlds becomes staggering. With numbers like these, the question isn't whether life exists elsewhere in the universe. The question is, why haven't we found it yet? This is known as the Fermi paradox, named after physicist Enrico Fermi, who asked, where is everybody? If the universe is so vast, so old, and contains so many potentially habitable worlds, why haven't we detected any signs of alien civilizations? The silence is deafening. Perhaps intelligent life is incredibly rare. Perhaps civilizations destroy themselves before they can spread across the stars. Perhaps the distances are simply too vast to overcome. Or perhaps, and this is the unsettling possibility, we're the first. In a universe 13.8 billion years old, across 2 trillion galaxies, we might be the first species to look up and ask, are we alone? Now, let's talk about something closer to home, but equally extraordinary. Your body contains approximately 37 trillion cells. Each cell contains DNA, a molecule that carries the instructions for building and maintaining you. If you could uncoil all the DNA in a single human cell, it would stretch about 6 feet long. Now multiply that by 37 trillion cells. The total length of DNA in your body would stretch about 34 billion miles, enough to reach from Earth to Pluto and back. Twice. You are carrying inside you right now a molecular thread that could span the solar system multiple times over. And that DNA, it connects you to every living thing on Earth. You share about 60% of your DNA with a banana, about 90% with a mouse, about 99% with a chimpanzee. Go back far enough, and you share common ancestors with every plant, every animal, every bacterium on this planet. We are all, quite literally, family, branches on the same evolutionary tree that began growing nearly 4 billion years ago. But let's venture beyond Earth again, because there's something you need to know about the night sky. Most of the stars you see up there are already dead. Remember, light takes time to travel. The light from a star 1,000 light years away left that star 1,000 years ago, when humans were building castles and fighting with swords. If that star exploded in a supernova 500 years ago, we won't know about it for another 500 years. We're seeing ghosts, ancient light from stars that may have burned out centuries or even millennia ago. When you look up at the stars, you're not just looking at the present. You're looking at a museum of cosmic history, a gallery of the past. Each star a photograph taken at a different moment in time. Here's another mind-bending fact about scale. There are more atoms in a single grain of sand than there are grains of sand on all the beaches of Earth. Think about that. Pick up a single grain of sand, so small you can barely see it. so light you can't feel its weight. That tiny speck contains roughly 50 quintillion atoms. That's 50 quintillion atoms in something you'd need a magnifying glass to properly examine. The universe is not only vast in scale, going outward into space. It's equally vast going inward into the quantum realm. We exist in the middle, at a scale between the incomprehensibly large and the impossibly small. And now, for the final fact, the one that should truly make you feel the weight of cosmic insignificance. The universe doesn't care about you. It doesn't care about any of us. There is no cosmic plan, no special place reserved for humanity in the grand scheme of things. We are not the center of the universe. We're not even the center of our own solar system. We live on an ordinary planet orbiting an ordinary star in an ordinary galaxy in an ordinary region of space. The universe is not hostile. That would at least suggest it acknowledges our existence. No, the universe is simply indifferent, magnificent, beautiful, awe-inspiring, yes, but utterly indifferent to our struggles, our triumphs, our very existence. And yet, here's the paradox that makes it all worthwhile. You exist, against all odds, in a universe that didn't have to produce life, consciousness, or meaning. You are here. You are made of atoms forged in the hearts of ancient stars. You are the universe experiencing itself, a way for the cosmos to know its own story. In you, dead matter has somehow organized itself to become aware, to feel wonder, to ask questions about its own origins. Carl Sagan said it best. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. Yes, you are insignificant. Your planet is a mote of dust. Your civilization will eventually fade. The sun will one day expand and consume the earth. Galaxies will drift apart. Stars will burn out. In the end, trillions upon trillions of years from now, the universe may fade into a cold, dark, empty expanse where nothing can happen anymore. But right now, in this moment, you are alive. You can think. You can feel. You can love. You can look up at the night sky and understand, even in some small way, your place in this vast cosmic story. You are insignificant, yes, but you are also miraculous. The fact that you exist at all, that the universe has produced something capable of contemplating its own existence, is perhaps the most extraordinary fact of all. So the next time you feel small, remember, you are small. Cosmically, laughably, impossibly small. But you are also a part of something so vast, so ancient, so beautiful that it defies comprehension. You are a child of the cosmos, born from stardust, given the incredible gift of consciousness in a universe that didn't have to be conscious at all. You are insignificant.